Hi, everybody. Today we are going to talk about multiplying and dividing rational expressions. Okay, so if you remember, I said that rational expressions are just a fancy way to say fractions. So let's remember how we used to multiply fractions. We would multiply the numerators by each other and the denominators by each other. So to multiply these fractions, I would have 4 times 3 in the numerator and 5 times 7 in the denominator, and I end up with 12 over 35. And then I say, can I reduce that? I can't. They don't have any common factors, so 12 over 35 is my answer. We're going to do the same thing with rational expressions with variables. So I'm going to have 5x times 3 in the numerator, and I'm going to have 9 times x squared in the denominator. 15x over 9x squared. So now I say, can I reduce that? Well, 15 and 9 can both be divided by the same number. They can both be divided by 3. So I'm going to divide this by 3, and I'm going to get 5, and I'm going to divide this by 3, and I'm going to get 3. So in my new answer, I'm going to have 5 in the numerator, 3 in the denominator. So next I have to look at my x's. So I have x to the first and x to the second. So if I have 1x on top and 2x's in the bottom, I can get rid of 1x on the top and 1x on the bottom, and it leaves me with just an x on the bottom. So 5 over 3x is my answer. Okay, next example. Again, don't let this scare you. What we are going to do a little differently is we're going to write each expression in its own set of parentheses to try and not get too confused. So in the numerator, I have 6x squared, and that's one expression. I have 2x plus 3y, and that's squared, and squared just means I have another one, 2x plus 3y. In the bottom, I have 2x plus 3y, and I have 5x. So now I get to see if there's any sets of parentheses on the top and the bottom that are the same, and if there are, I get to cross them out. Well, 2x plus 3y and 2x plus 3y gets to get crossed out. So now let's see what we have left. We have 6x squared. We have 2x plus 3y, and we have 5x. So if I look at 6x squared and 5x, they have an x in common. So I'm going to take one x away from each of them. Okay, so I'm going to erase that 2 and erase that x. And that's just because the x squared and the x can be divided just like they could in the last problem. So this right here is my final answer. Okay, so now I have something where I want to look at it and see if I can factor anything on the top and the bottom first and get this as simple as possible. So I can factor z squared minus 1 because I need two numbers that multiply to -1 and add to 0. So two numbers that multiply to -1 and add to 0 are z plus 1, z minus 1. Okay, and then I still have that 8 on the top that I'm multiplying by. I have this, oops, too many squiggles. I have z to the third, and then two numbers that multiply to 4 but add to 5. So z plus 1, z plus 4. Now I look and see if there's anything that I'm able to cancel out. I'm able to cancel out z plus 1. So on the top, I'm left with 8 times z plus 1. On the bottom, I'm left with z to the third times z plus 4. And that's my answer. Okay. So for the next part, we're going to learn how to divide. And in order to divide fractions, we have to remember what a reciprocal means. So a reciprocal means that we're just going to flip the top and the bottom. So 2/3 would become 3/2. 1/5 would just become 5. -6 would become -1/6. So all we did was flip the bottom and the top of the fraction. That's what reciprocal means. Let's try an example. Okay, so if this was my original fraction and I wanted its reciprocal, the top becomes the bottom becomes the top. So the reciprocal for 8x minus 3 and 5x squared, the bottom becomes the top becomes the bottom. Okay? Don't get all twisted up just because that looks crazy. We're still just finding the reciprocal. So the top is now going to be what was on the bottom, and the bottom is going to be what was on the top. Doesn't matter that it's crazy. We're not doing anything with it except just finding the reciprocal. So what was on the top becomes the bottom, what's on the bottom becomes the top. So now we're going to take that idea of the reciprocal and we're going to apply it to division. When I divide fractions, the first number stays the same. The operation changes to multiply. I find the reciprocal of the second. And now I just multiply like regular. The numerator times the numerator. The denominator times the denominator. Okay, so I'd have 8/3, and that's my final answer. The process is going to be the same when we're talking about expressions with variables. Okay. My first rational number stays the same. The second rational number flips. Oops. Okay. The second rational number flips. So the top becomes the bottom and the bottom becomes the top. And now instead of dividing, we're multiplying. And it's still just going to be numerator times numerator, denominator times denominator. So I end up with 4x on the top, 6x squared on the bottom. But I can reduce that. 2 goes into 4 2 times, 2 goes into 6 2 times. Okay, they each have an x to give. So on the top, I'm going to get rid of the x, and on the bottom, I'm going to get rid of one of the x's. So 2/3x is my answer. All right, so now we're going to leave the first expression alone. And now we're going to multiply, but instead of having x plus 5 on the top, it's going to go on the bottom. Now, x squared minus 9 can be factored. We need two numbers that multiply to -9, but add to 0. It's going to be x plus 3, x minus 3. And remember, every expression should be in parentheses. And now we're going to be able to cross out what's in common. So these go away. What we're left with is x minus 2, x minus 3 on the top, x plus 5 on the bottom. One more. So the first fraction stays the same, y plus 3 over Well, instead of y squared minus y minus 2, I'm going to go ahead and factor that. Two numbers that multiply to negative 2 but add to negative 1, y minus 2, y plus 1, and we're multiplying. But instead of 2y on the top, 2y goes on the bottom. Now I need two numbers that multiply to 3 but add to 4, y plus 1, y plus 3. I'm going to put those in parentheses also. So now we're going to look and see what we can cancel out. Y plus 1. So on the top, we're left with y plus 3. How many of them are there? There's 2. We're left with 2y and y minus 2. And that's our final answer.